Hello students, today we are going to start the second topic of chapter 2, relations and functions. Since we had studied about Cartesian product in the previous video, now we are going to start the relations, right? Now what is a relation? We had studied in the last video that a Cartesian product is the maximum compatibility between any two non-empty sets. Let me start with an example, then we will study relations in depth. This is A cross B. Right? If I write the Cartesian product of these two non-empty sets, we have simply to connect every element of A to every element of B, right? So the ordered pairs are formed this way: 1, A, 1, B, 1, C. Then we have 2, A, 2, B, 2, A, 2, B, 2, C. Right? This is the Cartesian product between two non-empty sets. Now, what is a relation? I had told you earlier, like Cartesian product is the maximum compatibility between two non-empty sets. So we cannot go beyond this Cartesian product for any kind of relationship between these two sets. So whatever relation we are going to form, it has to be out of these ordered pairs only. Whatever relation we can find. The answer to that relation will be out of these ordered pairs only. What does that mean? Either we can have all the ordered pairs as our solution, or we can have few. So this is the concept that we have learned in sets. When we have a set which contains a few or all the elements of a set, it is called subset, right? So relation is a subset of A cross B. It is a subset of A cross B. Subset may be proper or improper. Like we can have either few of these elements in our relation, or we can have at max all the elements in our relation, right? This is subset of A cross B. Now, see, what we had learned is Cartesian product is nothing but connection of every element to every element without any prescribed relation or link or any property which is combining these elements to each other. There is no requirement in case of Cartesian product. But when we talk about relation, now what is a relation? When we call someone that he's my uncle, okay, or she's my aunt, or she's my cousin, or she's my friend, we describe a relation with some name. You know? We need to have some kind of connectivity. Like we cannot call a person I'm related to, just a person is moving on the road, I can say I am related to that person unless we have some kind of relationship with them. So here the relation has to be defined. That means there has to be some link between the elements of A and elements of B. When that link is defined, then we might be getting few ordered pairs out of this, right? Now, here I have taken that example in which it is a bit difficult to form a relation. So, or you can say, if we take the order in their occurrence in their size, like Y is R is a relation from A to B. This is the way we express. R is such that it is a relation from A to B such that, and after that we write what is B is equal to what from here, right? B is A plus 1 or 1. You can say B is equal to 1 or B is equal to 2. Or what is the order here? Like you can write it in elemental form, like the element at second order is equal to number at second order, right? What does that mean? Like 1 is related to A. 1 is related to A, or we can find 1 here, since we have to write the elements of this set first. So we can write 1 comma A, 2 comma B. Now see, if I have to maintain the order, Here we have three elements. Here we have only two. We don't have three here. So we can only write relation between these two elements with these two elements of the second set. So the ordered pairs which we get according to the relationship, that we have to take the numbers and alphabets at the same place. Like this is the first number, this is the first letter in order. This is the second number, this is the second alphabet at the same order. So these are the only two ordered pairs that we have got as our solution to this relationship. I told you, you will be getting a few or all. At max, we can have all these ordered pairs, but that will be a very less chance. So these two, this is the solution to the relation that we have defined here, right? So a relation will have the ordered pairs out of the Cartesian product only, right? Let me take one more example. Like if we have A, 1, 2, 3, B as 1, 2, 3, 4, right? Now, if we write Cartesian product, what is A cross B? 1, 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4. That's it, right? Here we have n of A is 3 and n of B is 4. So in Cartesian product, we must have 12, right? 12 ordered pairs that we have got. This is a set of Cartesian product. Now what is that? I can define 2, 3 relation from the same sets. Like let R be a relation from A to B. Now we can link the elements of A to B in different orders. Like once I can say y is equal to x, or y is equal to x, or if you are taking an A and B, you can write B is equal to A. Now we have to find ordered pairs in which B is equal to A. Like if we are writing the ordered pairs as A comma B, B has to be equal to A. See how many ordered pairs do we have here? 1, 1. B and A both have to be equal. 1, 1, 2, 2, 3, 3. Right? So ordered pairs which are satisfying this relationship are 1, 1, 2, 2, 3, 3. Right? That's it. Now these are the ordered pairs. Now you can see R is a proper subset of A cross B. Proper means improper subsets are those when the whole A cross B has to be taken. But that is not the case. We have few elements being taken in this relation. That's why R is subset of A cross B. Right? Now we can define one more here. R is a relation from A to B such that, how can we define, like B is A plus 1. Right? B is A plus 1. That means the second element will be the values of first element added to 1. Now see, what are the possible values of A we have? If we take A as 1, what is B? 1 plus 1, that is 2. See, do we have this 1 comma 2? Yes. So write here as 1 comma 2. If I take A as the second possibility of A is 2, what would be the value of B? It is 2, 2 plus 1, 3. So what is that ordered pair? This one, 2 comma 3. And the third possible value for A is 3. So what would be the value of B? B is 3 plus 1, 4, right? So it is 3 comma 4, right? So here also R is a proper subset of A cross B. So this way we can have relations between two non-empty sets for whom we have learned how to make Cartesian product, and then we can find a relationship between the elements of A and B that forms the relation between these two sets. For relation, we have to define some connection between the elements. We have to link them according to some property, which was not in the case of Cartesian product, right? Next, we have to see what is the domain of, I would like to erase here only and explain you what is the domain of a relation. Domain of relation. You know, domain means what are the possible values of the first elements, the inputs. Inputs means the first elements we are taking from this set. And have we taken all the elements here? Because see, that is the difference we are going to learn in case of functions. In case of functions, domain may not be the same as the domain in the relation because we have different properties. But in case of relation, we simply write all the first elements, set of first elements of the ordered pairs, right? Set of first elements. Now see, this is, let this be R1, let this be R2. So what is the domain? Domain of R1, set of first elements. 1, see, these are A's, small A's, right? So 1, 2, 3. The set of first elements is domain, right? Domain for the second function, R2. What is that? Here also it is 1, 2, 3. All the elements have been used, right? This is called the domain of the relation. Now, what is the range? Range of a relation. That means the set of the second elements. Set of the second elements of the relation. Now, what is that? The range for R1. What is the range for this? Here, the range is the set of second elements. That means the values of B, 1, 2, 3. For the first relation, set range is 1, 2, 3. For the second relation, what is the range? See the second elements, 2, 3, 4. So here the range is 2, 3, 4. Right? So this was the domain and range of a relation and how we form a relation. Right? So I hope the things are clear regarding relation. If you have to ask something or if you want to join classes for this chapter, do let me know and contact Urban Pro for my profile. Thank you.